All right, now that we have our predictions based off our different curve fits, we need to evaluate them. So two of the easier ways to evaluate a function, a curve fit of a function, would be using the MEA, or the mean absolute error, and the mean absolute percentage error. In fact, you can see that's what this over here is. So how do we calculate them? Well, we sum up, for the mean absolute error, we sum up all the observations minus the predictions. So the observations are what really happened. The predictions are what we have over here from our equation. We subtract those and then we add them all up. Notice that we've got the straight bars here, which means the absolute value, which means that we only want to know what the pure distance is. It doesn't matter positive or negative, just how far apart it is. And then we divide it by n. MEA, same thing, except the only difference is once we do that observation minus the prediction, we divide by the observation. That gives us a percentage error for our function. Absolute error gives us the absolute value of the numbers that we go through. We're actually going to do the absolute error first, because then I can use that, since you can see that that's part of this here, and then I can use that for the absolute percentage error. Now, Excel makes this pretty easy, but what we're going to do is we are going to calculate out the absolute error of each one first. So, and then we're going to take all of them, average them together to give us the mean absolute error. Okay, so let's go. We're going to equal the observed one is going to be this one up here. So that's the demand that we're observing, and then we're going to subtract from that for our linear what our prediction would be. So if you look at that, I did that, it comes out negative. That's because I did not do the absolute function. So if I do ABS, that returns the absolute value, and then I bracket that, and there we go. So the absolute value would be 6.74, and as I drag this down, it's going to index these values all the way down through here, all the way down through here, and so let's just go and do that right now. And so there we go. If we click on this to check, we can see indexed exactly like we wanted to. Now, if I go and I drag this over one, well, the problem is you can see that gets us to power, which we did want, but the demand messes up. So what do? Let's go back to this initial equation. So the C4, I do want that to go, because I want to drag that over to exponential, so I want it to go from, the F19. I want it to go from F to G to H, and then I want it to go down through the rows, Now, as I look at the C4, the thing is I do want it to index the rows. I want the 4 to change to 5, 6 to 7. I don't want the C to change. I want that to always be set. So what I'm going to do is I'm going to put my $sign in there. And so I'm going to double click. Oops. I don't want it because this is a merge cell down here. That's what the problem. It tried to drag it down. So I'm just going to drag that down, and you'll notice that none of the values at all changed, because nothing was going to, because I've just locked it in, so the column isn't going to change. And then what I'm going to do is I'm just going to take this, I'm going to grab it, I'm going to drag it over, and then we'll just check a couple of these. You can see that drag that should be a power. It's exactly what I want, and it has the demand in the right spot. It just didn't change the column. Okay, so that's all set up here. And so now we do the mean absolute error. How do we do that? Equals average, and we're just going to average up all the absolute errors. And then I will just drag this over. I will get all three of those, and we can see based on the absolute error, it looks like that the power equation is the best. Let's do the percentage error though. Okay, percentage error. We're going to cheat a little bit because I've already figured out part of it, which is the observed minus the predicted, and then I'm going to divide that by the observation. And so in this case, the observation would be the demand. And just like before, I don't want the column to change, I want everything else to change. So I'll put that in, and it gives me 14.98%. We'll drag that over, and I'll just click on that to make sure that's working exactly like I wanted it to. And then I will go and I will drag all of that down. And so now I've completely put together the percentage errors for each of these. And we'll do the same thing. And actually, we'll just click on that, check. Yep, that dragged exactly like I wanted it to. And so we're going to do the same thing. We're going to go equals average and tab. And I'm going to average up this column. Close that up. And there we go. So now as I look at this, the mean absolute error, so my linear, on average, I'm 6.1 off the demand for each one. For the power, I'm 4.23 units off the demand for each one. And the exponential, I'm off by 4.84 units for each one. The other way that we can look at it is, on average, the linear equation's off by about 9.5% each time. The power equation's off by 6.18% each time, and then the exponential equation is off by 7.17% each time. So basically, based on both of these measures, we are looking like the way to go is going to be my power equation. Because both ways that I look at it, that tells me it's the best thing. Okay. So now what we need to do is we need to build our profit model, and we're going to be using our power equation. So let's go to the profit model. And look at this. Parameters of the best fitting power curve fit. I already knew it was going to happen, so it was set up. So what we're going to do is I just want to pull it from the previous sheet, because if that number changes, I want that number to stay the same. So I'm going to go equals. I'm going to go back to the previous sheet. I'm going to grab that constant, hit enter, and then equals, go back to that sheet, and grab that constant. I do not want to just do a copy and paste, because I want to make sure that they are the exact same and everything changes. And so the other thing I'm going to do is I'm going to Control-C to copy this, and then I am just going to paste the format here. Those little hatch signs, pound signs, number signs, or for your generation called a hashtag, that is an error that we get with Excel, but it's not really an error. All it's saying is, hey, you haven't given me enough room to show you what's going on. So I just want to make this just big enough so we can see it. So I am going to just double click right here, and that's going to auto size what's going on. Okay then. So now let's build our model together. And so what are we going to do? Well, let's build our profit model. So we have the unit cost to produce. It's $250. That is my cost. My decision variable, it's in red. This is what I get to choose. I am choosing what my price is going to be. Okay, so as we go back to here, our equation is all based on what the price is going to be. That's what we've pulled over. So now let's build what is our predicted demand going to be? Well, our predicted demand is going to be the constant times B11, which in this case is our trial value, and we're going to raise that to our exponent. So our demand in hundreds, using this equation at $450, is going to be 62.919, or 62,919 sets of golf clubs. From there, we're going to do our revenue. So how do we get our revenue? Well, our revenue is going to be that predicted demand, and then we're going to take that predicted demand and we're going to multiply it by our unit price. And so 25,000. Now, once again, since the demand's in 100, the revenue is in hundreds. So it's not 25,000, it's 25 million. Okay, and total cost. Well, our total cost is going to be the demand that we have, and we're going to multiply that by the unit cost to produce, so 15 million. We have our profit saying here in hundreds. We probably should have done that for all of them, so there is no confusion. So let's just do Control-C. I'm just going to copy that part there. Let's make things a little bit more correct, because we want to be clear with all this stuff. And so what's our profit? Our profit is going to be revenue minus costs. Okay. And so from here, we're going to have to figure out maximum profit and the best price. Let's do the maximum profit first. So we're going to do a data table. Big surprise, data tables, especially in this class, I love them. So let's bring our profit down, profit in hundreds there, and we're going to do a one-way data table. So we're going to insert, actually go to data because it's where all the fun stuff is. We're going to go to data table. It is going to be a one-way data table, column input because everything here is in the column. And so this is the unit price. So we're going to tell it, I want you to change, I want you to change this. And we hit OK. And there we go. And then we can sit here and go, okay, what's the best price to have? If we go conditional formatting, we'll go back to our top 10 items. Oops, we didn't want to do that though. Home, conditional formatting, top 10 items, more rules. We're going to change that to the top 1. And then we're going to format that to fill, and we're going to say fill it in green, and say OK. So, based on this, 520 is the best price. Okay, so we come back up here and we go max profit. We're going to use the MAX for the max function. We're going to pull all that down, have it done. That tells us 10,292 and best price. Well, we could go look at conditional formatting and find out where those match. The issue with that is every single time that we do that, we have to re-look. And what we're trying to do in Excel is we're trying to automate this stuff as much as we can. And especially this will come into play and say that we had that best price and then we had to look that up into a table using a VLOOKUP. So I want to automate Excel giving me back that best price. I don't want to have to do it by hand. How do we do that? That's what we're going to do in the next video.